Hello and welcome to another video. In this video we're going to be going over double a number represented as a linked list. And so this one's pretty straightforward. You have a linked list that represents a number, so like in this case it's 189. And you want to just return that number doubled as a linked list. So 189 doubled would be 378, so you just return linked list 378. And in this one, this number doubled is 1998, so you just return 1998. So there's a bunch of ways you could do it where you could just go through and get all the digits in an array or something and just do the math and then make nodes after that. But I'm going to show you how to do it in place. I think it's kind of cooler, and there's a lot of stuff that you need to do. There's a lot of problems for like linked list addition or all these things, and you can kind of use this kind of same template for all of them. So I'll kind of show you. So let's say we have this number, 983. Basically what we want to do is we want to double each digit, but we want to start at the end. Because if you think about it, like if we just do a normal math operation, 983 times 2, like you take the last digit, right, and you multiply by 2, then you get this digit and you multiply by 2. And so there's a couple things you need here. So you need a carry in bit, we'll call it CN, and if you did like computer science, it's pretty common. So essentially this will basically always be 1 or 0. And then you're gonna have a carry out, but we can reuse our carry in as this. So our Cn here will start off as 0, and the Cn just represents like the if you're carrying over 1 to the next thing. Because for example, if we had like 3 times 8, we'd get a 4 and then we'd carry a 2. So the Cn is going to be used to, so normally in addition it's either 1 or 0. Here it can be like more than 1 because you can have like 3 times 9 and so on. So I'll kind of walk through that. So let's actually demonstrate that. So instead of 983, let's use another number. So let's say it's like 987 or something. Yeah. So basically what you'd want to do is in a normal number multiplication, you'd say, okay, I'm going to take these, multiply by each other, and my carry in right now is 0. So my total is these two numbers multiplied by each other plus the carry in. So it's, numerator times 2 plus Cn. So in this case, we'd get 14 plus 0, so we get 14. And then the number we actually want to write down is this number mod 10. So here we'd get just a 4, right? Because we care about the current digit, and then we also care about the C out. So here we're going to have a 4, and then we're going to have this carry section. So the carry will be the same thing. So num times 2 plus Cn. Now this is just floor divide by 10. So in this case, we'll get a, so 14, so we get a 1. So basically now our new carry bit turns into a 1. And then here you get 16 plus our carry bit, so you get 17. So you have a 7, and then you have another carry out 1. And then here you have 18 plus the 1, so you have 9, and then you carry the 1. So you'll have this number left when you're done traversing your linked list. So we can traverse our linked list, and I'll kind of show you how to do that. And then we'll have the 1 left over. And after we traverse all 3 nodes, if we do have a 1 left over, once we make our number, so in this case we have 974 as our number, we need to actually make one more node that's a 1. And then that would be our answer. So let's kind of walk through how to do this using a linked list traversal. So essentially, like I said, you'd have a carry in here. We'll make it 0. And basically, you're going to want to start at the end. So how do we start at the end of a linked list? We can just reverse it. So the first thing we're going to do is reverse our list, which we'll write a list reverse function this time because we're going to use this multiple times. So list reverse. Now we have the right order we need to traverse. So essentially, we're going to start over here, and we're going to say, okay, so our total is our carry in times the number, or carry in plus number multiplied by 2, and then what's our new carry in going to be here? So it's going to start out as 0. So here we have 6 times 2 plus 0, so our total is 6, and this is the total mod 10. And our carry out is 0 because we didn't have to like carry anything, right? It's just 6. It's not like 16 or anything. So we can just replace this with a 6. Then we're going to go to this node, and we're going to say, okay, our total here is 8 times 2 plus our carry in. So 8 times 2 plus 0, so 16. Divided by, or not divided by, modded by 10. Because we only want one bit here. So 16 modded by 10 is just going to be 6. And our carry out is going to be that same number, 16, except now we divide by 10. So we get a 1 here. So we put in the total. Then we come over here and we say, okay, our total now is 9 times 2, 18, plus our carry in, so 19, mod 10, so 9. And our carry out, is 1, right? Because we have 19 divided by 10. So our carry out is 9, or our carry in the next one. So basically, we write a 9 here, which we already have. And then we say, okay, actually what we can do here is instead, you can do it here, but I'm just going to instead reverse the list back now because we want our number in the original order. So we're going to reverse the list back to have our original number. So reverse like this. And like that. And now we're going to have like the head of this list, and we're just going to check, do we have that extra 1? We could have put it in earlier, which is fine too, but I'm going to do it at the very end. So I'm going to reverse it back. And if I have a 1, that means I need to add a 1 in front of my number. So I'll just add a 1 here. Or whatever number I have, right? If it's non-zero, I can have something that's, I think technically actually because you're only multiplying by 2, you'll only have a 1 always. You'll have a 1 or a 0. But essentially you would return this. And so for this number, for this 999, that's how you have a 1. Same kind of thing. You just multiply by 2, keep track of the carry bit. So maybe you can call this like even carry if you want to instead of cin. And then just keep getting the new number, and then just check, do I have a carry at the end? Put in the carry, return your linked list. So to summarize, we return because we want to start at the end, or not return, we reverse because we want to start at the end. We go digit by digit, multiply by 2, and add the carry. And then we check if we have a 1 carry at the end or not. If we do, we'll add a 1 in front of our number to get that result. And you can do this for a bunch of problems where you have to like sum a bunch of numbers, or, you know, let's say you had 2 linked lists and you have to multiply them by each other. You would do the same kind of thing. You'd have a carry, you'd have a total, and you would like keep track of that, and you would like go bit by bit, and you can do stuff in place like that. So this is how you do it without actually getting the whole number beforehand. So that's what we're going to code. So let's do that. So we're going to write a list reverse function this time. We didn't last time, so this is pretty easy. So list node, just a standard list reverse, list node head. And we're going to assume that the list node is never empty. It'll still work for empty, but whatever. So we can say list node cur head, list node previous equals null. While, or in fact, you can even use the head node technically. So we'll just use that, or we'll call this like node or something. We'll do this. So we'll say while node does not equal null. And then this is where you just do a normal list reverse. I'm not going to talk too much in detail about that. It's just like a standard problem. You can look into that one. Pretty easy. You just make a temp and so on. So we can say next or something equals node next. Then we can say node next equals previous equals node equals next. And finally, our previous node will be the head of the linked list once this loop is over. So just pretty cookie cutter list reverse. So return previous here. So we can just call this function to reverse our list. So let's do that, start off. So we can say head equals, or we can even like, let's just say head equals reverse list of the head. So now the list will be reversed. So the head will be like, we'll have our starting list, and the head will be over here now, and this will all be reversed. Then we're going to want to save this, but we're also going to want to have another variable here. So we could say list node cur equals head. And then we want our carry bit, so, or not a bit, but just a carry. So int carry equals 0. Then we could say while cur, I guess it's fine, while cur does not equal null. So essentially, if you remember, what we need to do is we need to multiply our current value by 2 and add the carry bit. So we can say like int total equals cur val times 2 plus the carry. So like I said, I keep saying it's a carry bit. It's not a carry bit. That would be in like assembly or something. Anyway, so it's this, and then you mod it by 10 because we just want the like the ones digit here. So that's the total, and then our new carry will be the same thing divided by 10. And in Java, pretty easy. If you just do integers divided by integers, it's the same thing as the floor divide. So you don't need to do like math floor or anything for integers because it'll basically just chop off the decimal anyway. Yeah, and then we just make our current node's value equal to this. So we can say cur val equals total, and then we just move our node forward. So you could say cur equals cur next. So after we did this, basically our list got reversed. So like, let's say this was our original list. Now our list got reversed, and now our current is out of bounds, and our head is over here. So we want to reverse it again to get this node. So we can do that. So we can say, head equals reverse list again, head. And now our head is the start of this list with all the values being correct. Now we just have to check if we have that one carry or not. So we can say if carry doesn't equal 0, we'll add one more node and make it point to the head. So essentially, if the carry bit exists, we'll add another node, give it the carry value, and make it point to the head, and that's what we'll return. If not, we'll just return the head of the list. So we could say head equals the new list node with the value of carry, and its next is going to be the old head. Then we just return the head. All right. And there we go. So pretty good. So like I said, you could do this in a bunch of ways. You could get an array and get all, like, do the operation on your numbers. In Python, in fact, you can probably just get a huge number. Like, I think that'll be fine. In Java, you can't. So that's the other thing I didn't think of. Because this number's 10 to the 4th, you can't. There's no like integer that will store something, or a long or something that will store this big of a number. So you have to do it number by number in like an array. Yeah. And so this is the way we did it. So basically, we did 2 list reverses and then just in place stuff. So this will be time of n and space O of 1. Kind of similar to yesterday where we did 2 list reverses. The same kind of thing. So basically, a lot of these problems are basically just, do you know how to reverse a list? And figure out how reversing a list can help you doing most of these. You can do, like, imagine you had this number plus another number like this, right? Like, let's say you had 2 linked lists and you had to either add their values or multiply their values or whatever. You can kind of do the same thing. You could be like, I want to start at the end. In fact, there's a problem like that if you want more practice with that. I want to reverse them, and then I want to, go by the least significant digits first, and then I take my answer and like reverse it again or something like that. So same kind of thing. So hopefully that was helpful. If it was, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.